So now we're going to look at molecular compounds, which your book calls type 3 compounds. These are between 2 or more nonmetals. Now, hopefully you have already downloaded the notes that I put on Google Classroom on naming type 1, 2, and 3 compounds. They're the polyatomic ions, which I've explained already in previous videos. Type 1 and type 2 are ionic compounds, so you actually have charges. You have a transfer of electrons, whereas now type 3 compounds are between 2 or more nonmetals bonded together. They're going to share electrons instead of actually exchanging electrons. So we can have a multitude of compounds with only 2 elements. For instance, if we have nitrogen and oxygen, we can have a half dozen different compounds that involve nitrogen and oxygen. Whereas type 1 and 2 compounds involve the transfer of electrons. Now you get these large network solids. You're not going to find a single sodium with a single chlorine. You're going to find this big network solid of sodium and chloride ions. And the formula unit is the simplest whole number ratio of the elements in that compound. So for instance, in NaCl, you have 1 sodium for every 1 chlorine. Whereas with magnesium chloride, because magnesium forms a 2 positive charge, you have 1 magnesium for every 2 chlorines. These ones are actually called molecules. So this would not be a molecule of sodium chloride, it would be called a formula unit of sodium chloride. It's not a molecule of magnesium chloride, it's a formula unit of magnesium chloride. So just for fun, I like to abbreviate formula unit FUs. So how many FUs do you have? How many formula units do you have? Now, with molecular compounds then, because they are sharing electrons, we have to use a different naming scheme. We can't do the crisscross, make the superscript subscripts, because that's not going to tell us how the compound actually forms. If we look at water, for instance, water is always H2O. It's never H3O. That's in fact the definition of an acid. It's not OH. That's the definition of a base. It's always H2O. And the reason is because oxygen needs to gain 2 electrons. If we look at the periodic table that we did a couple videos ago, here is oxygen. Oxygen needs to move over 2 places to become like a noble gas. It needs to gain 2 electrons. Well, hydrogen over here doesn't want to just give away its electron, it's going to share it. So since hydrogen only has 1 electron, what we're going to do is figure out then, so the hydrogen is not going to give away its electron, it wants to share its electron. And since it can only has 1 electron, you need 2 hydrogens reacting or bonding with the 1 oxygen to form H2O. So these are going to be molecular compounds. So here's the stair-step line. So your 2 elements are going to be to the right of that stair-step line. Now in order to indicate then how many of each we have, we're going to use these prefixes. So if you have 1 element, it's mono. If you have 2, it's di. 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa. Just like a stop sign is an octagon. 9 nona, 10 deca, 11 undeca, and 12 dodeca. Now I never ever teach type 1, 2, and 3 compounds at the exact same time because type 3 are so easy to name. Everybody wants to name everything as a type 3, and it's not. Everything is not a type 3 compound. So for instance then, if we had a compound and we had NO, NO2, and N2O. All 3 of these are actual compounds. Now, the only rules that you have to remember when naming a type 3 compound is the first element is you do not use the prefix mono on the first element. If it's only the second element, there's only 1, then you do use the prefix mono. So it's carbon dioxide, not monocarbon dioxide. Carbon monoxide, not monocarbon monoxide. So in the same idea then, this one would be called nitrogen. And just like we had with our other compounds, we change the ending to "ide" monoxide, which brings me to the next rule that you have to remember when naming molecular compounds. If you have oxygen and your prefix ends in an A or an O, you drop that A or the O off. So it's not monoxide, it's monoxide. And again, it's only with an A or an O. So pentaoxide becomes pentoxide. It just flows much better. NO2, a primary component of smog, and we kind of have a bad air quality day today. This would be called nitrogen, not mononitrogen, nitrogen dioxide. And the same idea here then. Now, instead of having only one element, we have two elements. So we have a 2 down here. So the prefix 2 is di. So this one is going to be called dinitrogen monoxide. Names is now dinitrogen monoxide is often simply called by its old name nitrous oxide. And you might find nitrous oxide if you go to the dentist and you get the bozo-nose. That's nitrous oxide, commonly called laughing gas. It is also the propellant in whipped cream. So the canned whipped cream, and we look right down here and we have ingredients, and right there, propellant, nitrous oxide. And you can take nitrous oxide, inject it into the intake manifold of an internal combustion engine, like a car, and you get nitrous oxide. And NOS is one of the brands of nitrous oxide. That's why it's called NOS, nitrous oxide. So it's pretty simple to name a type 3 compound. Say we had P2O4. Well, again, 2 is di, P is phosphorus, prefix 4 is tetra. But again, whenever you have an A or an O on your prefix as the last letter, and it's with oxygen, you're going to drop off the vowel on the prefix. So instead of calling it tetraoxide, it's simply tetroxide. It just sounds a lot better than calling it tetraoxide. Really quick story, always reminds me of the South Park episode where they went to the planetarium, but the person that ran the planetarium couldn't say planetarium, so he always said planetarium. And kind of reminds me of tetraoxide and pentaoxide. Now going the other way, if you have the name already, then you can figure out the formula really easy because the prefix tells you how many of each element. So say, for instance, we have this compound, trisilicon pentafluoride. So the prefix tri means 3, silicon is Si. So we have Si, 3, and then penta is 5. Notice that the A is still on here because you only drop off the vowel if it's with oxygen. Fluoride is fluorine, so that is going to be then F, not Fl, 5. Si3, F5, silicon pentafluoride. And that's how you name and figure the formula for type 3 compounds.